To find the roots in Microsoft Excel, try and error, that means you are going to enter the function manually. So in my case in here, let's say I'm going to put at this column, I will put the value of x, and here I'm going to put the function x. Okay. So let's say that I want to try if my function is equal to -1. If my function is equal to -1, I want to check what my function is going to be equal to if -1 minus cosine of -1. So how to write this one in Excel? You will write equal, this is x, minus the cosine bracket sine of x. So when x is equal to -1, my function will give you the answer of -1.5. So the function here is not 0, so this means -1, it's not the root of this function. So let me try 0. I'm going to write again the function, which is equal to x minus cosine x, and I hit enter. So if x is equal to 0, my function is still equal to -1, so it's not 0, so that means 0, it's not the root of this function. How about if I try 0.5? It's equal to -0.377, so 0.5 is not the root of the equation. Let me try the value of 1, and also 1.5, and the value of 2. Okay, and see how is the answer is going to be. So when I'm going to drag like this, I found the values in here. This is my table, and this is all the values. So from the table here, from this table, can someone tell me where is exactly my root is going to be like? Where is the root of the function here? Can someone tell me, based on what we have learned last 3 weeks? Between 0.5 and 1. Why you are saying that? Because it's why it's between 0.5 and 1? Anyone can tell? Exactly. How do you know that? It's because the function is changing the sign. When the function changing the sign, that means it crossed the x-axis. It's between 0.5 and 1. Okay. You want to see that one graphically? What you need to do is highlight these 2 columns. Go insert, go for the charts, and take this chart. And you can see it from here. When x is equal to -1, the answer is -1.5. When x is equal to 0, the answer is -1. When x is 0.5, it's -0.3. And when x is equal to 1, the function changed the sign to 0.4. So that means between 0.5 and 1, my root is going to be here. So this is my x lower, it's 0.5, and x upper is equal to 1. But actually, it's this value is what? Is this value it's 0.6? Is it 0.7, 0.8? Nobody knows. It's not clear. For Microsoft Excel, there is a function that we can use. That function, we call it goal seek function. This one. The goal seek function, it will help us to find the exact value, or to find us the true value. So this is what we are going to use it today to get the fruits of the equations. So what we are going to do, first we are going to enter the value of x in one cell. Then we are going to put the function in one cell. Then we are going to use the value or the function of goal seek to find the roots of the equation. So this is what we are going to do. Okay, let's start from here. We will write this is x, and this is the function of x. I will write it back here. Let's say I'm going to put the value of 0 here, and I will put my function here. It's equal to x minus the cosine of x. And I hit enter. So the answer is -1. We are saying here it's my root, it's between 0.5 and 1. So let's try. If I put 0.5, what I'm going to get? -0.37. So let me try 0.6, -0.2. Let me try 0.7, -0.06. Let me try 0.8, 0.01. I can see from here, I am trying to try a lot of values manually. I'm changing the values manually by myself at x to see the effect on the function. I don't want to do this one manually, since Excel can do this one automatically for me. So Excel is going to try a lot of values here to make this function is equal to 0. This is what we call it. It's the goal-seek function. So how to use the goal-seek function? You click on the data ribbon from Excel, click on the data ribbon. You're going to find a button here. We call it what if analysis. There is a small arrow here. You click, then you're going to find the goal-seek function. So again, you are at home, click on the data ribbon. You will find the button what if analysis. Click on goal-seek function. When you open the goal-seek function, this goal-seek function, it has 3 parameters to be filled. 3 parameters. The first one is set the cell, which is the function cell. Set the function cell. In my case, in here, my function cell is B11. So set the function, which is this one, B11. I want to make my function is equal to 0. So make my function equal to 0 by try and error, or by trying a lot of values at A11, which is here. So when I click OK, you are going to see that it's Excel, it's rotating very fast and showing some values in here. He's trying. Okay, he found it. So the answer that make my function here is equal to 0, or the accurate value of this intersection here, it's 0.73909. So this is considered it's the root of my function that make my function is equal to 0. Okay, is it clear? Do you have any questions about goal-seek function?
No, sir.
Okay. By the way, goal-seek function, or what I just explained right now, if you have the textbook, if you go for the page 192 on the textbook, you're going to find exactly what I'm talking here about. This is the example 7.71, and this is the way and the explanations how to do this one. Okay, you are going to find also the explanations of what I just said right now. Okay. Next, we are going to talk about determining the roots of 2 functions, which is called its nonlinear equation or simultaneous equations, which is here that we are having 2 unknowns, x and y. Manually, if you want to solve nonlinear equation, which method that we are going to use? If we are going to solve nonlinear equation to find the value of x and y for 2 equations or 2 functions, what's the name of the methods we are going to use? Okay, I'm not going to answer that. You need to find by yourself. We already explained about this. It seems that you are not reviewing back your class. Okay, in my case in here, I am having 2 function. 2 function is having two unknowns, which is x and y, and I need to find the two values of x and y that make my functions here is equal to 0. So the example is giving me two initial value that x is equal to 1 and y is equal to 3.5. I am going to use Microsoft Excel. I'm going to use something we call it's the solver function to find the true value for this example. So my true value is given. It's supposed to be x is equal to 2 and y is equal to 3. So I need to achieve these two values. Okay. So what I'm going to do, I'm going to use Microsoft Excel here. Okay, the first one, I'm going to put my initial values. So I'll say x is equal to 1 as an initial value is given, and y is equal to 3.5. So next, I'm having a function u of x and y is equal to, and the second function is v. My first function is equal to x squared, so that's mean this value square plus x times y minus 10. Enter. So the answer is negative 5.5. Okay. Second function is equal to what? It's equal to value of y, which is 3.5, plus 3 times the value of x times the value of y squared minus 57. And hit enter. So the answer is negative 16.75. When you are going to prepare your Excel file, you cannot write negative 5.5 by yourself. You need to write it in a form of equation as I wrote it just exactly right now. Okay, so to use the solver, I need to combine these two values together. I need to combine these two values together. So I am going to total them up. I find the sum of the square. So I'm going to square this value and I'm going to square this value in one cell. So it's equal to this value, square it, plus this value. I square the values just only to get rid of the negative value here. So I don't want to see the negative sign. So that's why I make this two square. So square this value plus square this value to get rid of the negative sign. Okay. So now these two function now is combined in one function. So if these two functions in here is equal to 0, that means this is my true value. You want to check that one? Remember, it's our true value. It's 2 and 3. If I put here 2, if I put here 3, this value here is going to be equal to 0. So this is my objective function. But now it's, since we don't know our initial value, sorry, we don't know the true value, how we are going to use the solver? Okay, the solver exists at the data ribbon at the corner, at the upper corner or the upper right corner of your Excel here. It's by default, it's not installed in Microsoft Excel. If you cannot find it, tell me so I will show you how to install it. Does all of you have the solver at the corner here? Yes or no?
No, sir.
Okay. If you don't have the solver, to install the solver, this is the steps. Click on File. So go scroll the whole way down to the left corner, left down corner. You're going to find the option here. Click on the option. So you can see from here, at the lower here, there is an add-ins. Okay, so again, click on File, Options. You are going to find here add-ins. You click on the add-ins. You are going to find here at the bottom there is Manage Excel add-ins. Click on the button Go. So you are going to find the solver here. Tick it and wait for a few seconds. You are going to find the solver here at the corner. So tick the solver, click OK, wait a second, you are going to find it. This is the way how to install. So now to use the solver, you just click solver. So the solver, it has some parameters that you need to fill in how to get the answer. So in the first thing that you need to fill in up is set the objective function. My objective function, it's the sum of the square, because this cell in here, it's combining both functions. So if this function here or this cell is equal to 0, that means this is the true value. So set the objective function, which is the sum of the square. I don't want to maximize it. I don't want to minimize it. I want to set it to the value of 0. So make sure that you are click on value of, and here it's 0. Okay. What's my initial value? My initial value, or by changing variable cells, X and Y. Then click solve. When you click solve, you're going to find that is the answer of Excel is equal to, and Y is equal to 3. Okay, this is the way. I will repeat back again. You are saying this one is 1. It's equal to 1, and this one is 3.5. Okay, click on the solver. So your objective function is the sum of the square. Make sure that you are click on the value of 0 by changing X and Y, and click solve. So you will get the answer 2 and 3. If you back to the example, you are going to say that is the true value that X is equal to 2 and Y is equal to 3. Okay, any questions about how to use the solver?
No.
Okay, so let's move to Matlab and find how to find the roots of the equation using Matlab. Matlab is more easier than Excel, because we are having a function in Matlab, we call it F0 function. F0, which is the function of 0 in Matlab, it's used to locate a root of a single function. How to use the F0 function in Matlab? The syntax is really easy. You just write F0, open a bracket, write the name of your function, and put the initial values. We are not going to use the option parameter in here, because the option parameter here is for optimization. So since we are just only finding the root, so we are not going to use the option here. So in Matlab, you're just only going to write F0. You will open a bracket. You will write the name of your function. Okay, then you are going to put the initial values. Okay, so our example here is we need to find the root of this function in Matlab, which is x power 10 minus 1. The true value of this function to be equal to 0 is x is equal to 1. This is the true value. Because 1 minus 1, the answer is going to be equal to 0. So let's see how we can do this one using Matlab. Okay, so the first thing in here, Okay, by the way, it's just only if you are going for the textbook. What I just explained about the nonlinear system, it's already here. Also, you can find this one here. And also, when we are talking about the Matlab, how to find the roots of the equation, also it's written in here. So everything is written in here. Okay. So now let's back to the Matlab and see how we are going to write our function. So the first thing, I want to write my function in Matlab. So I'm going to write like fx is equal to, I will put the add sign and open a bracket. My unknown value here is x. So my function is x power 10 minus 1. So I wrote my function like this. So I put the add sign in here. Add sign, that means it's my unknown is x. And this is the function here. Okay. So next, I'm going to put the initial value it's given in the example. So my initial value of guesses is x0 from 0 to 1.3. So I'm going to write in Matlab here my initial values of x0 initial 1 and 1.3, and I hit enter. So now I will write my function, which is f0, open a bracket. My function is fx, and my initial values is x0, hit enter. So I will get my answer is my root is equal to 1. Another things, if let's say that you want to change your, if you want to change your answer, or you want to change the function to be, if you want to change your function to be like the one we have in here for this example, let's change our function to this and see how is the answer is going to be. Supposed to be we are getting the same exact answer of 0.739. So let's see how. I will change my function to x minus the cosine of x. So I change it. So now I'm going to write the f0 function. f0 valid bracket y. Let me clear first. Okay. And this is my initials. And okay, it's because my initial values is wrong. My initial value is supposed to be starting from 0 to 1.3. Okay. So I can get the answer is 0.739, which is here is 7.39. Okay, my error here is like the error is coming here is because my initial value is from 1 to 1.3. Remember, it's my root exactly is between 0.5 to 1. It's not starting from 1 and forward. Okay, so this is the way how to can locate the root using the f0 function. So do you have any question how to use the f0 function? Any question? Okay. Okay, so last things to find the multiple roots. So we were talking about the multiple roots, and we are saying is mostly the polynomials in MATLAB is going to give you the multiple roots. So multiple roots is the serious limitations for Newton-Raphson standard and second methods and bisection methods. So we are saying for the multiple roots for the polynomial, it's better to use the modified Newton-Raphson. So actually how we are going to find the roots of the polynomials, this is the how to find the roots of the polynomials. But before we start to find the roots of the polynomials, there is something in here. In MATLAB, we cannot write the polynomials into this form. To present this polynomial in MATLAB, you need to write it in a form of vector based on the coefficient. So the coefficient for x power 5 here is equal to 1. The coefficients for power 4 here is 3.5. The coefficient of x cubed is 2.75. And the coefficient for x squared is 2.125. The coefficient for x is negative 3.75. And this is the constant. If you write these values here like 1, negative 3.5, 2.75, 2.215, and negative 3.875, and 1. MATLAB, you know that this is for power 5, this is for power 4, this is for the cube, this is for the square, and this is for x1, and this is the constant value by the order. So most of the time is in a descending mode. So you start from the highest to the lowest. So if you put your values into that form, so MATLAB, you'll know that this is your order for the polynomial. So let's represent our polynomial in MATLAB. Let me clear this. So my polynomial name here is A. Okay, so I represented my polynomial A. So now a question. If I'm going to ask you if x is equal to 0, if x is equal to 0, what's the answer of this polynomial? It's going to be equal to the constant value here. Correct. How about if x is equal to 3? If I said x is equal to 3, so that means you need to put 3 here, and 3 in here, and 3 in here, and 3 in here, and 3 in here, and use your calculator to find that value. In MATLAB, no need to do that. In MATLAB, there is a function, we call it, it's polyval. That polyval, it can test your polynomial with any numbers you want. Okay, so this function, we call it polyval, it will be evaluating the polynomial when x is equal to any value. X is equal to 1, x is equal to 3, to any values you want. Okay, how to write? You just write the name of polyval and the name of your polynomial and put the value that you want to test. So this is the value of x. Let's try. This is my polynomial A. If I write polyval, the name of my polynomial, and put the value of 0 first, so I get the answer is 1.25. Just right now, I ask you what's the answer when x is equal to 3. So just write polyval A. So when x is equal to 3, this polynomial will be equal to 42.5. How about if x is equal to 4? So it's 323.75. So this is the way how you can evaluate your polynomial. Okay. So this is one of the commands that it will help us to manipulate the polynomials. There is also another function that it will help us to find the derivatives. Okay. So let's say I'm asking you to differentiate this function of this, or to differentiate this polynomial to the first order. So what you're going to do? So it's going to be here, it's 5. This is going to be power 4. And here's going to be 4 times 3.5. This is going to be 3. And here 3 times 2.75. And this is going to be square. So here's going to be 2 times this value. And here's going to be x power 1. and this value will be gone, and this one is going to be your constant value. Okay, so this is how to make the derivatives manually. In Matlab, we can use this function, we call it its polyder, to give us the first derivative of the function. So how to write it? You just simply write polyder, open a bracket, put the name of your polynomial, and hit enter. So you're going to get the answers in here. 5, negative 14. If you back in here, as we said, this is going to be 5. 4 times 3.5, so it's negative 14. So this is the values. Okay, the question now here, it's polyder is going to give us the first derivative. So how about if I want to get the second derivative? Does anybody know any way that we can get the second derivative? Okay, there is no way actually to get the second derivative. What we can do, there is no function or specific function to find the second derivative. If we write in this form, we are going to get the second derivative. So the polyder A, the first time, is going to differentiate the polynomial one time. So when this bracket is finished, it will go for the second polyder, so it's going to be differentiated for the second time. Remember, this is 5 and this is power 4, right? So now 4 times 5 is going to be 20. So this is for the x3, this is for x2, this is for x, and this is the constant value. This is how to find the derivatives in Matlab. Okay, leave all this one up behind because this is just only how to manipulate the roots. Our target in here is to find the roots of these polynomials. And since we are saying this is a multiple root, so how many values can make my polynomial is equal to 0? The command, it's really easy. You need to write roots of your polynomial and hit enter. This is the command. You need to write roots of A and hit enter. So you're going to get those answer is making your roots. So this is a multiple root. So negative 1 will make your polynomial is equal to 0, 2, and 0.5. You want to try this? Let's check. If I write polyval, when x is equal to, my polynomial will be equal to 0. How about negative 1? Negative 1. My polynomial is equal to 0. How about 0.5? My polynomial here is equal to 0. So you can check using the commands of the polyval. So this is how to find the roots of the polynomial or the multiple roots. The command, it's really easy. You just write roots of your polynomial. Put the name of the polynomial. Okay, so that's all for how to find the roots of the equations. If you have any questions, please do ask. If not, so we can move to the last lab for this week, which is how to find the linear algebraic equations. Any questions how to use f0 function or how to find the roots of polynomial?
No, sir.
Okay, so this is the end of lab 4. And as I told you that it's you go for the page 196 in your textbook. All these commands you are going to find it on the textbook with the examples. Okay, this is the example 7.7. You can see this is polyder and all the commands, and this is how to find the roots of the polynomials. Okay, so now let's move to the lab of how to solve simultaneous linear algebraic equations. This week we had learned about Kramer rules, Navier-Gauss elimination, Gauss-Jordan, and Gauss-Seidel. So these 4 methods, it will help you to solve simultaneous linear algebraic equations to find what's the answer of x1, what's the answer of x2, and what's the answer of x3 to get the values of those. Okay, so if you download this lab, it's not that much there. You're just only going to find that this lab is contained just only one page. The explanation is how to find those values of the linear algebraic equation. It's the methods to do this one using the software. The idea is really simple. What we need to do is we need to find the inverse of the matrix A. So we need to inverse matrix A and times it with the matrix P to get the answer of all the unknowns. So remember, it's your linear algebraic equation. We are reshape it into this form. This is the matrix A, and this is the unknown. This is x1, x2, x3, and this is the constant B. What we need to do, we need to find the inverse matrix of A. We need to inverse it and times it with the matrix B. So this is what we need to do. Inverse matrix A and times with the matrix B to get the values of x1, x2, and x3. In both Excel and Matlab, we are going to follow exactly the same. Okay, so how to do this one in Excel first? By the way, it's this example in your textbook at page 311. And this is the example we are going to use. So first, open your Microsoft Excel and prepare your Excel file into this form. I will give you about 5 minutes. All these numbers you can refer to the textbook here. Okay, done. So let's see how to solve. Remember, we are saying that to solve for finding the values of x's, this is what we need to find at the end. What we need to do, we need to inverse matrix A. After we inverse it, we are going to times it with the matrix B. So the first step in here, how I'm going to inverse this matrix. This matrix is 3 by 3 cells. So how to inverse it? I'm going to highlight here 3 by 3 cells. And when you highlight, don't go anywhere and click like this. You need to highlight and move your hand from the mouse and write this. It's equal to M inverse. M inverse, this is abbreviation of matrix inverse. Open a bracket and highlight which matrix you want to inverse. I want to inverse this matrix. So highlight the matrix. And when you're done with the highlight, from the keyboard, click on the 3 buttons at once. Control, Shift, and Enter. Like this. Okay. This is what he's talking here about. You can see it on the example on the textbook, M inverse. And press Control, Shift, and Enter. Is it clear or you want me to repeat?
Repeat, sir.
Repeat, sir.
The methods for using Microsoft Excel or for Matlab to find the unknown of x1, x2, and x3, it's you need to inverse matrix A and times with the matrix B. So our first step here, I have matrix A. I want to inverse it. So how to inverse this matrix? Since this matrix is 3 by 3, so I need to highlight from Excel 3 by 3 cells. So highlight 3 by 3. And when you highlight, don't go click anywhere. If you highlight like this, then suddenly you click up here, you're not going to get the answer. You need to highlight and you have the same view like this. And you write from the keyboard, it's equal to M inverse, open a bracket, highlight the matrix that you want to inverse. We want to inverse this matrix. So highlight it. And don't close the bracket. Choose from the keyboard, you click Control Shift Enter. So you'll get the answer of 9, negative 18, 10. So this is the inverse of matrix. Got it? Okay, so now I have the matrix inverse. So what I need to do to find the x's, I need to times this matrix with the constant b to find x1, x2, and x3. So to find those answers, I'm going to use another function. We call it MMULT, matrix multiplication. So matrix multiplication, it needs 2 parameters. The first parameter is the inverse matrix and the constant b. So you need to highlight again 3 cells like this because I'm expecting 3 answers, x1, x2, and x3. Again, you are going to write it's equal to MMULT, matrix multiplication. Open a bracket. The first array is the inverse matrix. So highlight it, comma, then highlight matrix B. Again, Control Shift and Enter. So you're going to get the answer of x1 is equal to 1, x2 is equal to 1, and x3 is equal to 1. So this is the values of all the x's. So no need for you to do any nav goes, no Kramer rules, no need to find the determinations. You need to find the Gauss-Jordan, no need to normalize or shifting the rules or scaling or all these headings. Okay. Of course, during exam, you are not allowed to use Microsoft Excel. You cannot post your question in using Microsoft Excel. You need to show your final results is handwritten. You cannot use the tools. Okay. The only things that you can use Excel or Matlab is just only the assignment, because assignment, it has 1 question to solve using Matlab and Excel. But the other questions you need to solve handwritten. So you cannot just simply use Excel or your calculator or Matlab to show the final answer in the midterm or in the final. Clear? Okay, so this is how to find the linear algebraic equation using Microsoft Excel. How about to do this one using the Matlab? The commands also, they are easy. You can see it from here. I need to inverse matrix A. Then I need to times it with the matrix B. So in Excel, sorry, in Matlab here, let me clear this one first. Okay. I'm going to create the matrix A first. Okay. This is matrix A. And I'm going to create matrix B. 1, 8, 8, 9, 7, 2, this is matrix A, and this is matrix B. So how to do this? As we said, we inverse matrix A and we times with the matrix B. So the command, it's really easy. We are using a function, we call it inverse. So INV matrix A times with A. So inverse matrix A times with the matrix B. If you don't want to use the inverse matrix, you can use the backslash from your keyboard, which is going to give you the same exact result. So it's up to you. It's better to use the inverse matrix, so the examiner will know that is you understand that you need to inverse matrix A and times it with the matrix B. It's the same exact results. So this result also is somehow similar to the results with the Microsoft Excel. Okay, so you can use Microsoft Excel in case that you want to check your final answer, is it correct or no. But remember that you cannot post your Excel as a final answer in the midterm or in the final exam. So if you have any questions about those methods, you can see it here on the textbook. You can refer back anytime to those examples. 11.5 from the page of 313. If you have any questions, please do ask. If not, this is the last thing for today class. And I will see you inshallah for the next week. Another things I want to tell you all here is the assignment. The assignment one, we are going to post it on Google Classroom on Friday. So Friday, you are going to have assignment one. It's individual assignment. You need to solve it within 1 week. So we are going to give it on Friday. You need to submit it on the Friday after. It's individual, so one by one. If you have any questions, please do ask. If not, so thank you for today. Please, before you leave, I just want you to write your name, student ID, and the group. Any question?
No question.
Thank you very much. Take care all. Just wait for the assignment on Friday. When I post it, I'm going to give you the code for the Google Classroom and I'm going to post it in the group.